All right, we're moving on. Lesson 5, Unit 5. This is the last one. Then we have our test by Friday. So if you're not going to be here next week, make sure you have it done by Friday. You could even start it Thursday if you want. I'll have the review packet all ready to go. So remember, you also need your reference sheet, okay, for this test. So make sure that you have it. I'm not making other copies. If you lose it, make a copy. All right. Go to the New York State Regents website and you can print one out. Okay. So this is on the geometric series. We covered the arithmetic series a couple days ago or yesterday, whenever you watched it. And we haven't started the fluency yet, but they're going to be very similar, and you're just using formulas. So we start out like we started out the arithmetic as our formula for the sum using the summation symbol. So if we give you a recursive formula and they want you to find from 1 to 5 the sum, remember they give you the original, number 1, A1, okay, your starting point, and then you have to find up to A5. So when you find A5, remember the n minus 1 is always the value before. Okay, so we have A1, we need to find A2, A3, A4, and A5. Okay, so to find A2, we're going to take A1, which is this right here, and multiply it by 2. So 3 times 2 is 6. So every value we're just going to multiply by 6. I'm sorry, by 2. Okay, so then we have 6 times 2, which is 12. And then, previous term, 12 times 2, which is 24. And then 24 times 2, which is 48. Okay, strangers came in my room. Stranger danger. All right, and then you add all these values together. See, Nels? All right, so the 3, 6, 12, 24, 48. Add them all together, and you get 93, which is choice 3. Okay, now I'm pressed for time today. We have shortened classes, and I got to make some copies. So I'm going to skip over this exercise. I will touch on it in class. I don't know if I'll get to it before Thanksgiving. Otherwise, I'll touch on it after Thanksgiving. Okay, now we get to exercise 3. There is a formula that I'm going to jump ahead here, and it's going to be on the next page. Come on. All right, this one right here. They give you 2 formulas. Now, the one that we have in the Regent packet, the one they use in the Regents packet is this one right here. So that is the only one we will work with. So that is the formula we are going to apply on this example. So what do we need? We need A1. Okay, do we have A1? Yes. First term is 3. We need the R. The ratio is 4. We need that as well. And the N is the number of terms, 8 terms. So your A1 is 3. So the sum of 8 equals A1 minus A1 times R to the N. And A1 is 3, not 8. 3 times 3. Okay. And that's the times there. So 3 minus 3 times 4 to the 8th power, 1 minus 4. If I had more time, I'd redo the video. Unfortunately, I don't. So I'm going to show you how to put it in your calculator. So we have our fraction, and we have the 3 minus 3, and you have to make sure times, and you put it in correctly, the R was 4 to the 8th power, and then it is 1 minus R. So the R was 4 again. Enter. And you get 65,535. Some of these numbers are large. Don't worry about it. Okay, it can happen. So that is choice 4. Okay. And so like I said, the formula that they give us in the Regents exam is this formula here, and then this is the one we are always going to use. And you always have this accessible. Okay. Now we want to find the value of the geometric series below. Show the calculation that leads to your final answer. And I think this is the only one I'm going to do, and then we're going to be done. Okay, because the other stuff I'm going to talk about in class. All right, so you have a short video, and you can get right into the fluencies tomorrow. Okay, so what do we know? We know A1 is 6. R is the ratio. How do you go from 6 to 12? How do you go from 12 to 24? Well, you're multiplying by 2, so R is 2. Okay, now you have to find N. So N is the number of terms. So you could hypothetically do 24 times 2, 48 times 2, and keep going on and on and on and on until you get to 768. But then you might miscount, you might miss something. You can always do it that way, unless this number, what if this was like 76,000? Then you'd be doing it forever. Okay, so that would be very difficult to find your N value. So we use a formula that we used previously, the geometric sequence. So we have AN equals A1 R raised to the N minus 1 power. Okay, so my AN is 768. My A1 is 6. My R is 2. And I'm raising it to the N minus 1 power. Now we've already dealt with logs and exponents when you have variables in the exponents. So you have to solve by moving the 6 first. So when I divide by 6, I get 128 equals 2 to the N minus 1. Now, yes, you could log both sides, or you can see if 128 is a base 2. And that's just going in your calculator, 2 to the 5th, 2 to the 6th, 2 to the 7th, see which one works. And it is actually 2 to the 7th power. So 2 to the 7th power equals 2 to the N minus 1. And if you have the common base, you just take the exponents and set them equal to each other. So I have 7 equals N minus 1, therefore N equals 8. So you solve for your N. Once you solve for that, you can now plug into the formula. I'll go to a different color here. So we have S of N equals A1, 6 minus 6 times R raised to the N power all over 1 minus R, which is 2. Okay, and again, plug that all in your calculator. So you have your fraction. No, I don't want that. Okay, another one. So you have your fraction. All right, some stranger walked in. So here we are. A1. What was A1? A1 is 6 minus 6 times 2 to the 8th power all over 1 minus 2. And I don't care. Put it in. Oh, I didn't put it on the bottom part. So you got to go down below and 1 minus 2. Because sometimes you might not put the negative 1. So just fill it all in the formula the way it is. And there's your 1530, and that's your answer. Okay, so go back here, and the solution of this would be 1530. Okay, so short and sweet, 8 minutes. I know the beginning was a little shabby, and I don't have enough time to redo it. So I'm coming in a little late, so I'll see you in class.